So we're looking at a valve power amplifier build, and we've previously looked at these building blocks. These are custom building blocks for our amp, and we've got our heater supply, and then our high voltage supply and our bias supply. And we need to then go on and start to look at some of the other parts that we need, and the output transformer is one of the key items, and we need to make sure we've got a quality product there, because that's really going to have a big impact on how our amplifier behaves and how it sounds. So after a whole bunch of searching, I've settled on these Lundell transformers. These are, I think they're made to order, and this came from Sweden, ordered this from Sweden. Certainly not the lowest cost option, but they come with a very good reputation. So this is what we're going to use here. Alright, so I'm looking at using this off-the-shelf chassis here. This is just a standard Hammond Industries chassis. And the thinking is that we'll put our output transformer on the back here. And then at this side we're going to have our mains transformer. And some of the we've got our switching supply for our heater supply, etc. We'll get that on that side. And these will go in some enclosures as well, so you're not going to see any of that stuff. And then we're going to have our two output valves. I'm going to use KT88s here. So we've got two power stages that will feed that transformer, and then we've got our input valve and gain section there, and our phase splitter that drives the two output valves, and obviously a bunch of connectors and stuff on the rear panel. So I'll go and spend a bit of time now figuring out exactly where this stuff's going to go, and we'll start to mark up this chassis and start to drill some holes. Here we are then. I've got this thing marked up as much as I can really at this stage. So I've got all the rear panel and then my transformer mounts, etc. And I've got rough positions for the valves. I'll maybe kind of tweak them a bit, but we'll work in this back area and then see where that takes us. So I'll go and start doing some punching and drilling, and we'll see how it's looking after that. A while later then, and we've got everything mounted on the rear panel here. So obviously the mains connector and filter, and then we've got balanced and unbalanced connectors for the audio input, speaker connectors, and then I've got a D-type connector here. And I'm going to use this to monitor the bias on the valves, and we'll use it for control of an electronic attenuator. That's for the future, but we'll put in the connector for now. And then we've obviously got all this stuff on the top here. So I've got a bracket made for my output transformer, and then I've this bracket here. Our toroidal transformer will sit on the front, and then if we look at the back, we've got our switching supply in here. And I had a comment about using these supplies before. You know, someone popped up and says these eBay supplies are super unreliable, you know. And you got to ask, well, you know, it's true, we kind of know that, but why is that the case? And I'd already commented that the actual semiconductors on here were pretty good, so I didn't really have a problem with that. And what we find is that these supplies generally fail because they use garbage capacitors, and because they overheat. So we may look at changing these capacitors, but the main thing I've done here is that previously the output diodes were just on this little heatsink here, and I've taken these diodes off and mounted them on the back, so they are then connected to this big lump of metal here and through the chassis. So that's going to keep things a lot cooler, run things a lot more comfortably there, and hopefully we should have a good lifetime out of that. And if not, you know, what's going to fail? Well, you know, you're going to maybe replace the capacitors or whatever at some point in time, and that's going to happen regardless. So we'll see how that goes. I've marked up where my valves are going to go, so we'll look at that, and then we need to look at how we're going to mount this stuff inside here and work on these things when we've got all this junk here and when the valves are installed, etc. So we're going to take a quick look at that. Before I forget though, obviously this kind of junk here looks kind of unattractive, but we've got these nice shrouds that are going to just fit over there and kind of hide all that unpleasant stuff. So there'll be 2 of them on the back, and that'll make the thing look a bit smarter. So let's take a look at how we're going to deal with working inside while we've got all this sort of height going on here. So we're going to be spending a bit of time working on the inside of this thing, and you know, it could get a bit precarious if we've got all this stuff on the top here and then we're trying to turn it on its side or turn it on its back. We're going to break something or get frustrated at least. So I've gone to the lengths of making this cradle here, just out of some scrap wood, and I've cut some big gaps in the side and in the front there so we can get in and make adjustments, and we've still got some ventilation for the valves, etc. So this unit just flips into the top there. Let's have a go. So there we are. So as I say, I can still get in here. I might be able to tweak my bias and whatever we need to do, but we've got protection for everything that's under there, and everything's nice and flat and stable here, so we're not working in any kind of precarious situation. And then we can see inside I've put this plate in here that's going to mount some of our boards. And I'm just, the only reason for the plate really is so that I'm not putting multiple screw holes in the chassis there that we're going to see from the outside. So that's where we are there. And I guess the next thing is I've got this far now. I need to then drill the holes for my valves and put my valve sockets in. And so we'll go off and do that now, and then we can maybe start looking at wiring this thing up inside. So it's been a while since I looked at this, and you can see I've got my output valves, the sockets there are installed. That's all fine, and my original plan was to use these chassis mount valve sockets for the input stages as well. Just bolt them down and then do point-to-point wiring for the input circuitry, and then we'd have our bias circuitry here would secure somewhere and deal with that. But the more I looked at this and just thinking about it, it just wasn't sitting very well in my mind, and you know, I realised that a lot of the components were quite bulky, so doing point-to-point wiring, I just wasn't comfortable with it. It's just going to be a bit of a mess and hard to repeat, and so the reason it's taken some time to come back to this project is that I've gone ahead and done a dedicated board for this input section here. And if we look at it, the valve sockets are on the back, and we've got our trimmers for our bias and the AC and DC balance on there. And this is actually 3 distinct circuits on the same board. You can see the ground splits there, and so that'll just sit in here. We've got all our input circuitry, all the bias circuitry and everything there, so that's quite tidy, and a lot more comfortable than what it was going to be point to point. The wiring to the main valves is very simple, you know, that's really just to the output transformer and some resistors and power supply and stuff, so that's fairly straightforward. This is where all the kind of complexity was. So that's I'm fairly happy with how that's looking at the moment. And I think we're ready to go on and do some wiring up now. We'll see how we get on with that. So let's take a quick look at the schematic of this input board then before we start to wire it into the system. So we're coming in, we're AC coupled here via a nice film capacitor, and then we've got a grid stop resistor, and I've put a ferrite bead on here as well, and that's coming into our a first valve, which is an EF86 pentode, and this comes off our 170 volt supply via this anode resistor here. Got some cathode resistors as well, and then our feedback comes in on this point. So we come off the anode, another grid stop resistor, and then we come into this second valve, which is a double triode, ECC83 in this case. And this gives us our 0 180 degree phase shifted outputs. So they're AC coupled, and they go on and drive our output valves. But we've got our bias supply that comes in here as well through these 390k resistors here. So this is just a linear supply here that we can use to develop our bias, and then it's fed in through that point. So that's our circuitry. Let's have a quick look at the layout before we go on and start to put this thing together. So here's our board layout then, and this top right section here, this is our bias supply. It gives us somewhere between minus 30 and minus 60 volts. Just a linear supply, and that range will probably reduce once we find where the exact sweet spot is. We'll probably reduce that range just to make it easier to trim. So that's what's happening here. Got some further resistors for the bias here, and those sum into the output ports here and go off to our main power valves. The AC to those output ports is coupled in via these two big film capacitors here. You know, when you look at these big capacitors along with some of the other ones on the board here, this is what made me go down the route of doing this board as opposed to doing it point to point. I think this is just much more tidier and in control. Some big resistors on the board. This is a cathode resistor for the phase splitter, and then we've got our anode resistors here, and this is the variable resistor for the balance driving the anodes of these guys. It's their input valve obviously, and a bunch of resistors for the input for the feedback, and then this is the cathode supply going off to our 170 volt rail. So that's us. And then if we just rotate the board a little bit, you can see our input comes in here through this big film capacitor, and our feedback comes in here. So that's us. We'll go and take a look at installing this now and wiring it up. So here's our story so far. Now we've done a bunch of the wiring here. We've got our input board, and our power supplies are connected to our high voltage supply board here, and we've got our heater supplies on these white pairs. So that's all good, and our bias supply comes onto this board via this pair here. And we're obviously going to power this up in stages. You know, we're not just going to put the full voltage on this and hope it flies. We'll power it up in stages. So I've just got an input tacked in here. There's no feedback. Our transformers are not connected, and the main high voltage supply here I've just got isolated at the moment, so it's not driving this board. And what we'll do is we'll have a separate off-board transformer that we'll use to bring up this supply slowly. We'll rely on the onboard transformer and switching supply to do our heaters and bias. That's all, you know, we're not really too worried about that kind of stuff, but we're just going to be kind of careful and bring up the main supply slowly under our control. So that's it. We can, you know, there's not too much wiring to be done after that. We'll just take things carefully and make sure we're all good. We need to get our valves now. So these are ordered, and once we get these in place we can go on and do some more testing and the like. So here's the unit so far then. We've obviously got our valves now. We've got our valves installed here, and it's looking tidy enough with the shrouds on the transformers and the like. And we've got our adjustments here. These three holes are for our bias and bias balance between the two valves, and then the harmonic balance for our phase splitter. So that's all looking good. I want to turn the lights down here, and we'll have a wee look at these valves just as the heaters are glowing, and then we'll maybe start to look at some more detailed turn on and testing of the whole amp. Here we have the lights down then, and we'll just power up at this, see how it goes. It's been powered before, so it should come up a bit quicker than normal, but let's just see. Here we're starting to see things light up now. So that's a pretty satisfying step. It's a simple step, but satisfying nonetheless. So we'll just let that get up to full temperature there, and we'll take a break here. We'll come back with a second video looking at the sort of testing and performance of this thing, and so that'll be part 2.